We'll just pause for like 5 seconds so they can see this. We'll just pretend I didn't give any notes of it. Doesn't this remind you of good memories from math class? Chapter 9 of 2. So, multiplying, if we can have common factors, we can cancel stuff out. So yes, you could just go straight across the top, straight across the bottom, but that's going to get really ugly really quickly. So what you really want to do is factor if you can, and cross out common factors. Just like if you have a 2 on the top and a 2 on the bottom, you can cancel it out. If you have an x plus 3 on the top and an x plus 3 on the bottom, you can cancel it out. So that's kind of what we talked about factoring yesterday, because now we can use that to do these. And it's up to you on how you want to do this. If you write kind of small, or maybe you just leave some space, you can always factor above and below each one, and so you don't have to rewrite it every time. I'm going to rewrite it just since I have the board up here. But I'm just going to factor each one of these. So, right, this is like undoing FOIL. So I can say what multiplies to give me 9, that adds to give me -6, -3, and -3. And what about the bottom? How do I factor x squared minus 1? X plus 1, x minus 1, that's that difference of two squares, right? 2x minus 2, that's just a common factor there. I can just take a 2 out and get x minus 1. And x minus 3, I can't do anything. With me so far? Here's where the fun begins. If you have a common factor in the numerator with a common factor in the denominator, you can cancel them out. So if I have an x minus 3 up here and an x minus 3 down here, I get to cross those out. Because x minus 3 over x minus 3 is just 1. I have an x minus 1 and I have an x minus 1. I can cross it out. Yes? Anything that's left, we're just going to multiply across. And I really don't care which way you do it, right? Like you could say 2 times x minus 3 all over, on the bottom, all we're left with is x plus 1. I'm okay if you leave it like that, or if you want to distribute that to, you can, right? 2x minus 6 over x plus 1. I think that's why I multiply it back out when you already factored it. I kind of like the factor form better, but if you want to simplify it at the end because nothing else cancels out, you can. So that simplifies to that. Yes? Vague memories of that? Fun memories of that? Factoring and crossing out. Doesn't get much better. My favorite thing is when everything crosses out and equals 1. That's my favorite problem. You do all this work and then you get 1 out of it. What's different on this one from part A? It's division. So not only are you going to factor, but remember that division is the same as multiplying by the reciprocal. So as I factor, I'm going to flip that second one over. Right? So the first one is just going to say x plus 2. But then I can't factor anything out of that either. That's just 2x minus 3. Right? But I'm going to change that to multiplication. And I'm going to flip those two. So the x squared minus 4 is going to go on the bottom, and I'm going to go ahead and factor that as the difference of two squares as x minus 2 and x plus 2. And on the denominator, now goes the numerator. I can take an x out of that. And I get this, right? Questions on where we're getting that? Now we just cross it out. So what's my answer? What's left on the top? X. What's left on the bottom? X minus 2. Do not ever cross out this x with this x, right? Don't tell me the answer is -1/2. You cannot, like x minus 2 is together, so don't just start making up things. That's what happens. For some reason, I think I emphasize it's so much fun to cross things out that people just start making things up that they can just cross everything out. So, don't do that. Huh? What about if we're adding? We always teach multiplying and dividing fractions before we teach adding and subtracting fractions, because it's much easier to multiply and divide fractions, because you just multiply cross things out. But when you add and subtract, you have to have a common denominator, right? You're trying to add those equal parts. And so like I made one that had a common denominator already. And if they have a common denominator, what do you do with them? What would the answer to that be? How do you add fractions? Yeah. If the denominators are the same, you add the numerators and you keep the common denominator. Which means if it doesn't have a common denominator, that's what you're going to have to do. And they jump right in here in this book. They don't give you easy ones to start with, right? They give you stuff like this to start with. So I'll give you a minute to write it down, and then we'll start. You're getting a common denominator. We kind of just say common denominator, but we really mean the least common denominator. Because you could just take each denominator and multiply it all together and get this giant thing, but that's going to make things really complicated to match the book answer. So what we want to find is the least common denominator, which means we want to look at things that have factors in common. So this one's already factored out for you, but if the denominators weren't factored, that's what you want to do first. And you want to take what you need to do to get the least common denominator here. So if they share something, you don't have to take it twice, right? And you see how the first two fractions both have a 3x minus 2? You don't have to take it twice, you just have to take it once because it's in each of them one time. So like I know we're going to need a 3x minus 2 in my common denominator. What else am I going to need in my common denominator? Another x? Do I also need to put an x squared here? No, I don't have to put x squared, or I don't have to put x and x squared. Could I just say I need an x squared? Because the least common denominator between x and x squared would be x squared. So you have to take each factor the greatest number of times it appears. You do this with numbers all the time. It's just a little bit more thinking with letters. Like if I said, find the common denominator between 1/4 and 1/8, you wouldn't say the common denominator is 32. You wouldn't just take 4 times 8. You would say, oh, 8 is the first one that they share, right? They both have a factor of 4. They both have a factor of 2. So that would be the least common denominator. We'll practice a few of these. Oh yeah, I just learned this today. What happens if you take both the x and the x squared? If you take too big of a problem, or too big of a denominator, it makes things really complicated, right? It makes simplifying the top a lot harder. So you really want to try to take the least common denominator. Sometimes it'll work out that you can simplify it down. Sometimes you just get a big ugly mess. I remember last year, someone just multiplied all these together, and then they had like x to the 6th power on the top, and they just couldn't get it to simplify down because they didn't take the least common denominator. They just took all the factors together. So I guess maybe I should show more steps on this one. I forget. You tell me if you don't need this, but I should use my hand again, but I forgot. I'm going to rewrite each one of these on this one just to show you that we're going to make those denominators turn to these denominators. Minus x squared times 3x minus 2. The goal is you want to make one big fraction, but I just want to show you where this comes from, so maybe the next one we won't have to do all this, but we can do it every time if you want. How do you get a common denominator? you find the common multiples, you find that denominator, and then you have to turn this into this and do whatever you did on this denominator to get to this denominator to the same thing to the top, right? And again, just showing you really quick, I erased my numbers here. If I was going to make these a common denominator, I would make that an 8 on the bottom, and I would say, oh, I had to multiply 4 times 2 to get 8, so I have to multiply by 2 on the top to get 2 on the top. That's exactly what we're doing with the variables here. So to go from this denominator to this denominator, what do I need to multiply by? An x, right? That's all that's missing is an x. So all I have to do on the top is multiply by an x. So that's going to become 6x. What about on this one? To get this denominator to become to this denominator, I got the 3x minus 2, but I need that x squared, right? So I have to multiply, to make it balance, I have to multiply the top by x squared, which would be 5x squared. To get from this denominator to this denominator, what do I need to multiply by? 3x minus 2, so I have to multiply the top by 3x minus 2. And it's up to you. On these, it was just a number times a letter. We could just write 2 times 3x minus 2 here, or we could go ahead and distribute. I don't know what you want to do. I'm going to show lots of work since it's our first one. Let's switch to black there just for a minute. All right, you have to make the numerator balance out with what you did to the denominator. And then just like we said up there, if they have the same denominator, we're going to add them all together and keep the denominator. So I'm going to keep my denominator as x squared times 3x minus 2. And honestly, when I do these problems, this is where I don't do this middle step because I know it's one big fraction, but if you need the middle step, by all means do it. And I'm just going to say 6x plus 5x squared. Be really careful with that subtraction sign right there, right? That's minus 2 times 3x minus 2. So if you distribute that, that's minus 6x plus 4, right? So just watch your negative signs there. After you get the common denominator, you make the numerators match. All you got to do is see if there's anything to cross out or anything to combine like terms. So 6x and minus 6x, those are just going to cancel out. So I think my answer here is 5x squared plus 4 all over x squared times 3x minus 2. Taking 3 separate fractions and adding them together to one fraction. Can I cross out this x squared with this x squared? No, because it's addition, and if it helps you whenever you see addition subtraction, put parentheses around it to remind yourself that you can't just separate it to cross something else out, which means that would be my answer. Definitely a little bit more work. That was not fun. You'll get to cross stuff out on adding subtraction. Let's do another one. We have another quiz coming up really soon, like a real quiz, not a survey quiz. After 1-4, so we'll see. Maybe we'll do it next week. Maybe we'll do it Friday. I'll look at it and see what I want to do. I'd really like to get this activation done, but definitely like Monday or Tuesday of next week, we're gonna have a quiz over these sections of factoring and simplifying and doing stuff like this. So again, I don't collect your homework until the day of the test. But those quizzes are going to add up if you're not staying caught up on knowing how to do this stuff. What should we do first on this one? Factor the denominators. And I'm just going to do that underneath, and I'm totally fine if you do that as well. Right? I don't know why I wrote so big, but I think that's just going to be x plus 3 and x plus 3. And that's going to be x plus 3 and x minus 3. And then we have an x minus 3. It's really nice when the factors repeat themselves because it means your denominator isn't very complicated. If they don't have any factors in common, then you have to take every single thing out of the denominator, which is going to make a much worse problem. So this is actually a great problem because the factors repeat themselves a lot. All right, I'm going to do this all at once on this one, and then you can tell me if you like that or you want me to go back the other way. And I can go back and add it in if you want. How many x plus 3's do I need to take for this denominator? Chloe says 2. Who can confirm or deny that answer? Brandon, what do you think? How many x plus 3 should we take? For the common denominator, how many x plus 3 should we take? Chloe says 2, so why do you say 1 and she says 2? So why is it 2 is my question. Who can explain why we have to pick 2x plus 3's? You have to take each factor the greatest number of times it appears. And on the first one, there's 2, so you have to take both of them. Some people, in Algebra 2, when I used to teach this, some people would want to say we need to take 3 of them because they're like, hey, there's 3, but you only take it how many times it appears, the greatest number in each part, right? So 2 is the right answer. I just wanted us to kind of talk about why it's 2. And then, Brandon, you said 1x minus 3. And use Trevor's explanation for x plus 3 to tell me why is there only 1x minus 3. In each separate fraction, the most time x minus 3 appears is 1 time. All right, so that's kind of, if you're struggling with knowing what to pick, that's kind of what we're talking about here. So I'm going to say that is my common denominator. That's step 1. Step 2 now is let's go back and talk about what we need to multiply each fraction by to make that balance. So if this was my first one, and this is my denominator, what's missing from here that's over here? Just from this first fraction only. Right, so just from this one. Zach, I think I'm on you. So, look at this. Yes? Look at this. What's missing over here that we have over here? We're not looking at the top, though. We're trying to make the denominators match. So, x plus 3. Do I have an x plus 3 over here? And I have it over there? So we don't need that. I actually have 2x plus 3's over here, because this little 2 means there's 2 of them, right? Do I have 2x plus 3's over there? Yep, so I don't need that. What about x minus 3? Do I have an x minus 3 over there? No. So since it's missing, that means on the top, we also have to multiply by x minus 3. So I'm going to write over here 2x plus 5 times x minus 3. That fixes my first fraction. Yes? Okay, so since Zach, I'm back to you still. So what about the second one? If here's my second fraction, looking at the denominator, what's over here that's not over here? So what do I need to multiply by that would make these look the same? X plus 3. That's the right answer. So on the top, I'm going to say plus x times x plus 3. You run out of room every time. And then on the last one, I have an x minus 3. So what do I need to multiply by so that this would look like this? X plus 3 squared. And it's just a 1 up there, so I'm just going to put plus x plus 3 squared. Right? So there's not really a shortcut on these. I have to do pretty much the same amount of work that you have to do, because you really have to just make sure they match and work it out and multiply it out. It's not so much fun. All right. Multiplying out isn't nearly as fun as crossing things out, in my opinion. But questions on where I got this? This is x plus 3 squared, if you can't read that. Now I'm just going to work out the top. So I'm just going to FOIL all this out. So I'm going to get 2x squared. Are you okay if I just do the middle part in my head? Like minus 15x plus 5x minus 10x. 2 times 3 is 6, not 15. Just kidding. Minus 1x, I mean. Thanks. I don't know. I was doing 5 times 3 is 15. Minus 15. That's why I shouldn't do stuff in my head. And I'm going to go ahead and do the middle one. Really nice when it's all plus signs. You don't have to worry about distributing that negative. But then that's just going to be plus x squared plus 3x. And then the last one, when you take x plus 3 squared, right, that's just this right here. We just factored it. So it's just going to be x squared plus 6x plus 9. Don't forget your denominator. Combine like terms. 4x squared. That takes care of this, and this, and this. 8x, is that right? Plus 8x? Minus 6. And if you wrote x plus 3 times x plus 3 in the bottom instead of x plus 3 squared, that's okay too. Want to do anything else? I'm okay not doing anything else. Technically, we could factor a 2 out of the top of that. Do you agree with that statement? But you can't, there's no 2 at the bottom to cancel out, so that's where I'm kind of okay if you don't do it. So with a multiple choice question, just be aware that they could write it in different ways if you would want to match that to the multiple choice. If they factor the 2 out on the top, I think if you got that answer, you can match it up. Yeah? Whew. That was an exhausting one. Let's see, what's next? Oh, let's do this thing. We're almost done. I didn't even do the ugly one today. Tomorrow's the ugly stuff with like square roots and h's in it. And fractional exponents, that's smart too. Internet gave me problems I should focus on, and just so you know, all the ones I should focus on are the ugly ones from tomorrow. So we're like making sure we understand the day, and then we can do ugly ones tomorrow. This one's kind of ugly. Because it's like a fraction and a fraction. We call that a complex fraction. We don't like complex fractions. It'd be really nice if we could simplify the top of that first. So kind of just disregard the bottom right now. And if this wasn't here, right? If this wasn't here, what would you do to simplify that problem? Look at the back of the book. Ask your mom for help. Google it. What would we do here? What did we just do on the 2 examples before? I got time. Common denominator. What would the common denominator between x plus 3 and a plus 3 be? Seems like a trick question, doesn't it? Yeah, they have nothing in common. So your common denominator is just x plus 3 times a plus 3. It's actually the easiest type of common denominator is when they share nothing in common, because you just have to pick everything. I have no clue if like you have no clue what I'm saying, or if you're just like, this is annoying, I know how to do this, so I'm not going to talk to you. That's where I am right now. I just want you to know that. You think that's funny? We're gonna start. We can actually get on the Chromebooks now, which means we're gonna start using Chromebooks in here, which means I'm gonna start doing less talking, and you're gonna be doing stuff like answering things on computers, and it's all gonna show up here. So you're not gonna get this option of just staring blankly at me. Like next week, we're gonna come in and get our Chromebooks every day and do math on computers. Well, you're gonna still write stuff down. You're gonna answer questions so that I have any clue what you understand, because I have no clue right now where you are. So on this one, I need an a plus 3. On this one, I need an x plus 3. So if I distribute that, I'm going to get 2a plus 6. Be really careful with this minus sign, right? That's really like saying that's a negative 2. So that's going to be minus 2x minus 6. So watch those subtraction signs. With me so far? That's what you should be doing. Yes? No? I don't know. Let me the talk. So 6 minus 6 cancels out. I get 2a minus 2x over, I'm not going to FOIL that out, x plus 3 times a plus 3. And if I'm dividing by something else with a fraction, can I just change this to multiplying by the reciprocal? Right? So when you have a fraction in a fraction, right, that's a division sign. So right now this is x minus a over 1. So I'm going to change this big division sign to multiplying by the reciprocal. Right? So you can take that complex fraction and flip it around really easily. Which means I think this is better than adding and subtracting. Can I do anything else here? Chloe? Yeah. You can take the 2 out here and get a minus x. I'm going to cross that out. Oh. It's so close to matching, right? We could cancel it. We just need to take out, instead of a 2, what if we took out a negative 2? Oh, see, right? You see how a minus x and x minus a, they're exact opposite signs? So I'm going to rewrite this so I don't just get super messy on you here. Oh, that's not what I wanted to do. Problem solved. Just cover it up. So I'm going to say I'm going to take out a negative 2, and just to keep it in the same order here, I'm going to show you that that would make that negative a plus x. Normally I would just flip that around. Right? And now x minus a and negative a plus x, those are the same. They have the same signs. So now I can cross them out. So I think the answer you should give me is negative 2 over x plus 3 times a plus 3. How do you feel about that? Overjoyed, I think I can tell by your faces. Again, I believe this was chapter 9 in Algebra 2. How do I know that? I don't know, I'm really weird. But the other part of chapter 9 is you actually solve equations. We're just simplifying. But again, we're going to be getting into stuff very quickly into this class that you've done already in Algebra 2. That's why you should take Algebra 2 before you take this class. Because we just jump right in and reminding you how to do this stuff and getting into harder stuff. So definitely see me if you have a lot of questions. You're welcome to come in the mornings if you have questions that you don't want to ask in here. And again, hopefully next week when we start using the laptops, you can be more actively involved in this class instead of me just talking and you staring blankly. I have this little thing I was going to have you do, but I'm not going to have to do it anymore. Let me do this. This is 1 for day 1. And again, every third problem here, 12 through 21, multiples of and then 33 through 39. They don't all have 15 parts. But if it's multiplying and dividing, I think those are going to be a lot quicker. Adding and subtracting, you do have to get common denominators. Definitely check your odd answers in the back. But most importantly, make sure you're doing this because you are going to dig yourself a really big hole if you aren't staying out of your homework. Next quiz, probably Monday. Probably the next quiz we're going to have is going to be Monday. Maybe Tuesday, but definitely by Tuesday. Alright? So you actually have a few minutes if you want to get started. Or if you have other questions, ask.